Welcome to Thinking Mathematically, Chapter 10, Geometry. We're continuing now with Section 10.4, which is Area and Circumference. The objectives are use area formulas to compute the areas of plane regions and solve applied problems. Use formulas for a circle's circumference and area. First, we're going to look at formulas for the area of a rectangle and a square. The area, denoted by capital A, of a rectangle with length L and width W is given by the formula A is equal to L times W. The area, capital A, of a square with one side measuring S linear units is given by the formula A is equal to S squared, which is the same as S times S. Example 1, solving an area problem. You decide to cover the path shown in bricks. Find the area of the path. And this is probably an everyday experience because usually what you're trying to find is not a perfect rectangle or perfect square. So first, we begin by drawing a dashed line to divide the path into two rectangles. Now they have drawn it one way on this diagram. You can draw it the other way too. It doesn't matter. You just want to get two rectangles. Then use the length and width of each rectangle to find its area. The area is found by adding the areas of the two rectangles together. So you know that the green rectangle is 13 feet by 3 feet. You know that the blue rectangle is 6 feet plus the 3 feet. So it's actually 9 feet by 3 feet. Multiplying these out, you get 39 square feet plus 27 square feet, which is a total of 66 square feet. Next, the area of a parallelogram. The area, capital A, of a parallelogram with height h and base b is given by the formula A is equal to b times h. The height of a parallelogram is the perpendicular distance between the two parallel lines. It is not the length of a side. So the base is going to be the length of a side, but the height is going to be the perpendicular distance. Here's an example. We want to find the area of this parallelogram. We're given that the base is 8 centimeters, the height is 4 centimeters. So we put this into our formula and we find that the area is 32 square centimeters. Area is always a squared unit. Next, area of a triangle. The area of a triangle A with height h and base b is given by the formula A is equal to 1/2 b times h. So this example illustrates finding the area of a triangle. We're given that the base is 16 meters, the height is 10 meters. So we're going to substitute those values into our formula, and we get 80 square meters for the area of this particular triangle. The area, capital A, of a trapezoid with parallel bases A and B and with height h is given by this formula. A is equal to 1/2 A, which is one of the parallel bases, times the height, plus 1/2 B, the other parallel base, times the height. And this can be combined into 1/2 h times the sum of A and B. This example is to find the area of a trapezoid. We have the height is 13 feet, the lower base A is 46 feet, the upper base B is 32 feet. So substituting these values into the formula. We work inside the parentheses first. So 46 plus 32 is what we're going to do first. That gives us 78 inside the parentheses. Then we can work outside the parentheses. 1/2 times 13 feet, that would be 6.5 feet. So multiplying those together, we get 507 square feet. Next, a circle. A circle is a set of points in the plane equally distant from a given point, which is called its center. The radius r is a line segment from the center to any point on the circle. All radii, that's the plural of radius, in a given circle have the same length. The diameter d is a line segment through the center whose endpoints lie on the circle, is twice the radius. All diameters in a given circle have the same length. So, example 5, we're finding the distance around a circle. Find the circumference, which is the distance around a circle, with diameter 40 yards. The formula is C, which stands for circumference, is equal to pi times d. D is the diameter. So substituting the 40 yards in for d, we end up with 40 pi yards. And d is approximately 3.14, not d, pi. Pi is approximately 3.14. So multiplying 40 times 3.14, we get 125.7 yards. So the distance around this circle is approximately 125.7 yards. Next, we're going to look at the area of a circle. Which is a better buy? A large pizza with a 16-inch diameter for $15, or a medium pizza with an 8-inch diameter for $7.50. Well, just looking at it, it looks like they would be the same, pretty much, because the large pizza has double the diameter of the smaller pizza, and the price is double. But let's take a look at this. The better buy is a pizza with a lower price per square inch. We're looking at the areas of each of the pizzas. The radius of the large pizza is 8 inches because we were given the diameter, so we have to take half of that. The radius of the medium pizza is 4 inches. So the large pizza area is pi r squared. The squared is only for r, not for pi. So putting r in for the large pizza, we get 8. 8 squared is 64. So this is 64 pi square inches. Pi is approximately 3.14, or you can use 22 over 7, and we get approximately 201 square inches. The medium pizza, we do the same thing, and we get 50 square inches. So next, we're going to find the price per square inch by dividing the price by the area. The price for the large pizza is $15. We're dividing that by our 201 square inches, and that gives us a cost of 7 cents per square inch. Do the same for the medium pizza, $7.50 divided by 50 square inches. It gives us 15 cents per square inch. So in this case, the large pizza is the better buy, but that's not always the case. It just happens to be for this. And that concludes this lesson.